Okay, so this morning let's go through the homework questions that I gave you last Friday. Now, some of these were very challenging. So sometimes when the questions are this challenging or tricky to get into, the aim mightn't always be to get it fully out, but to write down, to provide the information that you know, and to get as many marks as you can, to work towards a solution and show your understanding of mathematical concepts. Okay, so let's look at the first question here. We're told that E is the midpoint of DC. So let's put in a little marks like that to show us. And we're asked to draw the image of the trapezium ABCD rotated by 180 degrees about the point E. So what does that look like? It means, so you would have done rotations as part of your junior cert work. If I had a pin here and I rotate that shape all the way around 180 degrees, means a semicircle. So D is going to end up at C. The image of D will be there. And what happens to C? It's going to end up at D. The image of C is going to end up there. So what about the rest of the shape? So we're rotating this around. It's like we're drawing a mirror image of it rotated around. And what happens is B goes 180 degrees around. It ends up over here. The image of B ends up over here, and A ends up down here. The image of A down there. And they've asked us, what kind of shape do we get if we do that rotation? Hopefully you can see that because this and this are the same length, and this are the same length, we end up with I haven't drawn it maybe the best way, we end up with a parallelogram. So that's what we were looking for there. So I haven't drawn it on boxed paper, but if you do it yourselves, hopefully you can show yourselves that it is a parallelogram that we get when we do that rotation. What is the area of this composite shape? Okay, now we haven't been given any measurements, so what are they asking about when they say something like this? Well, it's going to be the base multiplied by the perpendicular height. Okay, so that's the area for our parallelogram. And that means that it's going to be, let's say, H is the perpendicular height, and my base is, let's call that little a, the shortest distance, and this little b, the longest distance. The base is little a plus little b. Okay, so the area of the parallelogram is h by a plus b, and therefore the area of a trapezium is half of that, h over 2, the perpendicular height divided by 2, and then multiplied by a plus b, which is the formula that we have in the log tables, maybe written slightly differently. Sometimes we put the 2 under the h, sometimes we put the 2 under the a plus b. So in terms of explaining my formula, that's my explanation there, the maths that's done there. Let me just make that a little bit clearer. My h there is a little bit blurry. So the area of the trapezium is half the area of the parallelogram, and that's where we get the formula from. So what I expect happened with that question for some people was that you weren't sure what you're being asked, and for other people, maybe you couldn't remember what would happen when you did a rotation around a point like this. And maybe some people did know but didn't quite know how to draw out the shape. And don't worry if you didn't get everything here, because later on we will be coming back and studying more with transformational geometry. But this was information that you did study for junior cert. That doesn't always mean you remember it fully, and we don't always expect you to remember it fully, but I do expect you to make your best attempt and try and get something down for every question, even when you can't get it all out. Okay, let's move on. So to question 8 was a question that I would have expected most people to be able to attempt. Question 7, even though it wasn't actually that difficult mathematically, was difficult maybe in terms of how it was phrased. But question 8 was similar to what you would have seen in your notes. So we're told that 3 times the width of a certain rectangle exceeds twice its length by 3 centimeters. So let's draw the rectangle to start with. Just move my camera. Sometimes it switches off when I do that. So I've got a rectangle, and we'll say that this is the width and this is the length, and we don't know which one is longer than the others, but we know that 3 times the width is 3 centimeters bigger than 4 times the length. And I've done that backwards. So let me just cross that off for a second. 3 times the width is the same as twice the length plus 3 more. That's the first piece of information there. 3 times the width exceeds twice the length by 3. So 3 times the width is twice the length plus 3. If you're confused about which side to put the 3 on, which sometimes happens to me, just think about which one is bigger. So the bigger one is the one where you won't be adding to it. So I'd have to subtract from the bigger one to get to the smaller one there. So that's the first piece of information I'm given. The second piece of information is 4 times the length is 12 centimeters more than the perimeter. So again, I'm going to have 4 times the length is 12 centimeters more, add 12 onto the perimeter. But what is the perimeter? The perimeter is twice the length plus twice the width. So we can come up with a second equation here. 4 times the length is twice the length plus twice the width plus 12. And rearrange this so that it matches the same format as my first one. So I want the widths over here. Twice the width is minus twice the width is minus twice the length plus 12. What did I do there? I just rearranged my formula so that I have the widths matching up, the lengths matching up, and the numbers matching up. And now I can solve simultaneous equations, and we can see here that L will cancel straight away. And all I have to do is write down my equation 1, 3W equals 2L plus 3, and add on my second equation, minus 2W is minus 2L plus 12. 3 take 2 is 1. The L's cancel. 3 plus 12 is 15. Sub back into this. So 3 times the width is twice the length plus 3. That is 45 minus 3 is twice the length. So 42 is twice the length. Divide across by 2, and 21 is the length. Now, have we answered the question? Find the dimensions. Dimensions means length and width. And I have written them down, but what am I missing? My units. So the question included units, so my answer must include units. So my answer is that the width is 15 centimeters and the length is 21 centimeters. Make your answer nice and clear. Okay, so similar to one of the questions we did in the notes, I would hope that everybody mightn't do it exactly the same way as I've done there, but I would hope that everybody would be able to attempt that question and that most of you would be able to get it to work out. Moving on, so let's look at question 13. So question 13 has a regular hexagon, and we've learned because all of the sides are the same length, and I've got 6 of them here, 6 identical triangles, means that I have 60 degrees in the center here. And because they're also isosceles, I have 60 degrees down here, So I have equilateral triangles. So we're told that the radius of the circle is 5 centimeters, which means that all of these lengths here are 5 centimeters, okay, because they're equilateral triangles. First question asks us to find the size of the angle EOD. Well, EOD, as we've said there, it's 360 degrees divided by 6, which is 60 degrees. Find the size of the angle ODE. ODE. So they want the angle down here. And like I said, if this is 60, let me just draw this triangle out here. OED. So if this is 60, but this is an isosceles triangle, this must be 120 divided by 2. This must be 60 and this must be 60. So therefore it's an equilateral triangle where all sides are 5 centimeters. So this is also 60. They didn't ask us for an explanation, but that's where the explanation comes from. And finally, find the area of the hexagon ABCDEFA. So the area of the hexagon is 6 times the area of the triangle. Let's use this one here, OED. Now there's 2 ways of finding the area of the triangle. There's a formula in your log tables for the area of a triangle, which is 1/2 the base by the perpendicular height. But there's a second one as well, and it's 1/2 AB sine C. And there's a diagram that goes with that, where, sorry, my pen ran out, where it shows the sides A, B, C, and the angle there is in between them. So this formula is a nice way of finding the area of a triangle when we don't know the perpendicular height, but we do know the angle. So here we know the angle, and we can say that A, little a, one of the sides is 5, little b, the other side is 5, and the angle between them is 60 degrees. So the area of one triangle, of the triangle OED, is going to be 1/2 by 5 by 5 by sine of 60. You can just use your calculator to do that. So into my calculator, 1/2 by 5 by 5, which is 25, by the sine of 60 degrees. And we'll get it in third form, 25 root 3 over 4. Just leave it like that for the moment. So therefore the area of the hexagram will be that by 6. So multiply by 6. And we get 75 root 3 over 2 centimeters. Should we leave our answer like that? They didn't say anything about the format, so it's fine to leave it like that. Or if you want to, change it to 2 decimal places, 64.95 centimeters squared. Be careful, area means centimeters squared. Okay, if you didn't know about this formula, how would you do it? Because I hadn't talked to you about this formula. So the other way we could have done this was by dividing our equilateral triangle 5, 5, 5 into 2 equal right-angled triangles. So I would have 2.5, 5, and I could use Pythagoras to find the perpendicular height. So it's not like I can't find it, it's just this formula is very convenient. So most of you probably used Pythagoras, and you should have gotten the same area for the triangle there, 25 root 3 over 2. Let me just find the perpendicular height very quickly so you can check your answers. It will be the square root of the hypotenuse squared minus the other side squared, which is 5 root 3 over 2. So the perpendicular height was 5 root 3 over 2, and you get the same area then. Okay, thank you.